Today's video is part two in a series that I am putting together to really take a deep dive into estimating solar contributory value, specifically for residential properties. So last time we talked about the different income metrics. I'm sort of starting with the income piece of the equation. And we talked last time about the discount rate, cap rate, GRM, and landed on that for residential properties, GRM is not a bad place to start. So go, if you haven't already, go back and watch the first video so you can kind of get the gist of that piece. So we're going to dive in a little bit more specific to the GRM today. So what I wanted to talk about first was sort of the textbook, traditional method of using the GRM for contributory value. And this isn't just solar, this is just if you're going to estimate contributory value for an amenity using an income approach, this would be sort of the textbook way to do that. And that would be to take the rent with whatever amenity that you're studying, the rent without the amenity, and then the difference then would be the portion of that rent which is attributed to having the amenity. Very straightforward, makes sense. And then you take that rent attributable to the amenity, multiply it by your GRM, voila, there's your contributory value of the amenity. So if we wanted to look at this example, what that might look like with solar is you might say, okay, well, this property would rent for $1,700 a month with solar, $1,500 a month without solar. If I'm estimating a GRM at 150, then that $200 in additional rent would capitalize to a $30,000 contributory value for solar. So that is the traditional approach to that. But that does lead us to some questions that we need to consider. So is the GRM derived from sales with solar or without solar? That's pretty important, which we'll go into all these a little bit more. We'll track these rabbit trails. Second question that came up, can we apply a GRM equally to only a portion of the rental income? So that would be another question related to the GRM. And then how high is the quality and confidence of the rental data to support your with and without solar differential? And then does the reaction of tenants and short-term leases apply to long-term owner-occupants? Those are all really good questions that come out of that traditional approach. So can we apply a GRM, or this be the same thing in a cap rate really, to anticipate cost savings instead of the estimated impact on market rents? Yes. So this is super obvious if you're looking at a cap rate because you're looking at the net income, and cost savings has a direct impact on that. So that impact on income means that you can equally look at your gross number from which the GRM is derived and still have a good leg to stand on to say that, hey, why don't we look at cost savings instead of this market rent differential, especially when that market differential sometimes is very hard to support. That is maybe not great, which is why for solar, the cost savings component is nice because it's really easily accessible. You don't have to have a lot of information that's not very easy to come by as to what should I expect for cost savings. So that is a good reason to look at the cost savings component. But if we're doing that, The next question, is the GRM applicable to cost savings in the same way that it applies to rent? Probably not. So this is important. Back to where does your GRM come from? How is it derived? Um, Unless you're looking at a pool of data where you're developing your GRM from properties rented with solar, um, uh, that GRM is not going to necessarily apply, and I'll demonstrate that in a moment. So if that's the case, you're going to need to modify or adjust that GRM first. And even if you have that perfect pool of data, there's still some other considerations that you'd want to make. But I just noted here, if you have this perfect pool of data to develop your solar derived GRM, then you probably also have that really good pool of rental data to work with, and maybe that traditional method might work reasonably well. There's still probably some questions there, but um, if you have that, then this solar piece is probably not terribly complicated for you at this point, because you probably have a ton of data to work with. Even then, there's still some things to consider. But for the rest of us, where solar's more of a data limited environment in some ways, there's some other considerations. And here is the thing we really need to consider, and this goes beyond solar, what I'm about to discuss. Anytime you're using this income approach to try to estimate the contributory value of just a piece, you have to consider where GRM comes from. So it is the mathematical linkage between the income and the capital, which is the source of that income. So if we're talking about real estate, the capital is not uniform in composition. So we can see here, your GRM comes from, generally we can break it into a couple buckets here. Land value and improvements value. Those are all components of real estate that are very different, that both feed into what that GRM number is. That's very easy to see that those are different, and they will impact the GRM, because you can take an identical house and put it on a lot of twice the value, and your GRM is going to be very different for that property. And same thing with the improvements. Even the improvements themselves are not uniform in composition, because you've got short-lived and long-lived depreciation going on within those improvements. And so all of those also factor into the GRM. You can kind of see how that would flow. I mentioned last time that there's just I would think a relatively uniform or universal observation about newer homes having a higher GRM than older homes, and that's because that difference in depreciation is flowing up to the GRM number. So that is what needs to be considered whenever you are looking to apply a GRM number to solar. So what we're having to ask then, in order to apply the GRM to cost savings, we're going to have to consider those differences. We're going to have to adjust to reflect the differences between the composition of the capital, so that real estate, you've got land and improvements, and then differences in the improvements. You're going to have to adjust for the difference in the amenity, in this case solar, relative to the whole composition that went into that GRM number. So we need to adjust that GRM for land value. So if you add any improvement to the real estate, you're not adding land value, so that will not necessarily impact GRM in a uniform fashion. So lifespan. So the lifespan of your improvements as a whole is likely going to be significantly different than the lifespan of your solar PV system. And then there's going to be potentially differences in market reactions to how is the market reacting uniformly to the improvements as a whole and the solar. Those may or may not be the same. So the GRM would need to be considered for those differences. So that is what we wanted to what I wanted to discuss with you today was all of these things that go into the income component, and that all need to be considered. Now, the question you might be asking is, how do you do that? And that is what I discuss in my class when I discuss my technique, and I actually have the tool that goes with my technique. It's just a spreadsheet where I've got all of this already frameworked for you. All the calculation flow is already there to consider these differences. And this last piece, the differences in market reaction, is really going to now link us to the next piece of the puzzle, which is we have to link these things together. We cannot just take each individual approach in isolation. And so how do we combine approaches here? How can we take our market data, which is likely very limited in your market? Some markets are blessed with an enormous amount of solar data. Some has a lot more limitations. So we will talk next time on how to maximize the data that you have and link your approaches together.